So, I've been talking about this iterative cycle, and I think it's important to understand that, it's nice from a theoretical standpoint to present these things in flowcharts where it's like, oh, I just compile all these answers to these questions and I have everything in one shot. But the reality is, you're gathering information, you're bringing prototypes out, you're getting additional feedback on the prototypes, you're pulling that back into a conversation around, okay, well, does this mean I need to change a design? Do we need to consider another design or just tweak, or maybe it's nothing we need to respond to? And you just kind of keep looping around until you get to a point that you feel that you've got something that is good enough to address the user needs. An example might be if we're developing, say, any kind of a microfluidic cartridge that would be designed for, there's a range of different testers that use microfluidics. You might start your process by saying, well, what is it we need to do? Well, it needs to be able to draw material in and eventually, maybe combines into these channels. Okay, so let's try and make one. Did it do what we needed to do? Well, yes, but we're concerned about this aspect of the channel. It may be too wide, or maybe we're seeing some material pooling over here. All right, well, we're going to loop back around, maybe make a tweak, see if that works, maybe start showing it to somebody that might be the person who would have to inject into the cartridge, see how they respond to it, learn something else, like, oh, they're having a hard time getting their injection in, we have to make that change. So that's expected. The regulations definitely acknowledge that. FDA in particular, I think, has been very good at providing a lot of commentary that speaks to that in addition to the regulations. And the other nice thing about the regulations is as you go through this process, they recognize that you as the developer are basically becoming the expert in this space. So as long as you're capturing and scrutinizing questions appropriately, you can present everything to us as experts. Expect to get questions on it, don't expect them to just accept your word as your word. But they really want you to take ownership of this, is I think the underlying message. They want you to really approach it and say, I'm going to really make sure that I'm coming up with the best design that I can to solve this problem, and iterating it is going to need to be part of what I do. Question? Okay, all right. Okay, so now we're going to shift into talking about how you follow that process and eventually start determining what your outputs are. So we've documented some inputs, and typically that's a starting point, but it's going to require some more refinement to really get at the prototype that would become your product. You're going to be looking to try to understand in this point, what's the overall space that your design could exist into? So for instance, I've talked about a catheter length of 120 centimeters. Could the product still work at 119, 118? Where's that drop off before it gets to the point that putting the product in would just not achieve its goal? So you're going to be using a lot of, I don't know how many of you are familiar with Design for Six Sigma tools, designs for experiments. You start bringing in more of those tools at this point, and they're really focused on knowing you've got some element of a design that you're just trying to understand the edges of, and how far can you push certain aspects of the design while still retaining your performance. So you'll build ranges of things, you'll be testing them in various ways, bring that information back to see, okay, where's pass and fail, as much as possible. In some cases, you're never going to be able to do this for everything, and it doesn't necessarily make sense to focus on things that are less critical to the design than other elements, but a lot of refinement will happen, and those tools will be big drivers here. The other thing you'll be doing is determining and finalizing your components as you finalize your design. What materials are they made from? Biocompatibility and needing to comply with the ISO regulations on that. 10993 would be something that would influence what you're doing, but the way those regulations are designed, it will still trigger eventual testing. So it's really just making sure that you're selecting things and you are addressing any questions related to whether or not they may or may not pass biocompatibility at this point before you finalize a decision. So if you're working with materials that have a long history of being used in medical devices, you probably don't need to answer a tremendous number of questions here. So it comes in more when you're using a newer material or a newer formulation. You may want to do some preliminary evaluation to just make sure that you feel comfortable that it would probably pass the tests that you need to from a biocompatibility standpoint. You're going to also want to know about, does my product need to be sterilized? If it needs to undergo some kind of an end sterilization, what is that sterilization and what effect might it have on my materials? So you're choosing things that would survive a radiation sterilization if you need to plan for a radiation sterilization. The other thing that you do need to do here and think about are the test methods that you're going to use to measure all of these things. You probably have several of these in mind and they're known. In order to be able to withstand regulatory scrutiny, those test methods need to be validated as much as they can be. Because what they're most concerned about is ensuring that you're using methods that are repeatable, reproducible, that you're using equipment that's going to help you achieve those results, that you don't have tests that are so user dependent that they're not really giving you valid information. And you need to be able to know this now as you're finalizing your outputs, because once you finalize the outputs, the next question is going to be, okay, well, how do you confirm that you're meeting those outputs? How do you show that if I make something that meets those outputs, that I'm going to address the requirements that I identified initially?